Hi, my name's Kirk Jackson. Welcome to the Same Origin Policy talk presented at the OWASP Wellington meetup. Now, at the beginning of this talk, I'm re-recording because I messed up the original recording and didn't press start at the right time. So apologies if you watched this online and missed the first 10 minutes or so. I'll be stitching these together. I'm a security researcher at RedShield. Previous talks of mine are up available at hackhead.com. And if you want to view previous recordings of talks at our meetup, please go to the Google link below or go to meetup.com and look at previous OWASP Wellington talks. In our local meetup, what we're trying to do is cover the fundamental parts of web security, and we've done sessions on cross-site scripting and cross-site request forgery and mobile security and the OWASP top 10, and if you're interested in those, you really should just drop back into the previous meetups and look at the videos. But what we noticed is that underneath all these web security topics is something called the same origin policy. Like, it's the core of web security in the browser. And a lot of the other attacks and defenses and issues that you'll come up with in web security are not due to the same origin policy, but require the same origin policy to understand. So that's what today's session is all about, understanding the same origin policy. It's not going to be groundbreaking and new for you. A lot of the concepts that we'll cover you will recognize before, especially if you've done web development, but hopefully this will kind of bring it all together in a cohesive format for you. So this is what we're going to cover: what the same origin policy is, why is it important to web security, how does the same origin policy apply to BLAR, where BLAR is one of the many web technologies that you'll use, and how do you get around the same origin policy, or how do you do things around the same origin policy, maybe to embrace and extend the restrictions. But first, of course, before we talk about the same origin policy, we need to talk about what is an origin. And you've probably seen one of these before. It's a URL. It has some pretty familiar parts that you'll be used to. There's the scheme at the beginning, HTTP or HTTPS, or possibly even FTP or Gopher. You often don't see a username : password in URLs these days, but they used to be used more often. Then an @ sign, and then the site's domain. Port. If it's HTTPS, you don't need to put it. It defaults to 443, or if it's HTTP, it defaults to 80. And then there's the rest of the URL, so the path, the query string, and any fragment on the end. Now, an origin looks at just 3 of these parts: the scheme, the domain, and the port. And together that tuple makes up the origin. So if 2 web pages have the same scheme, domain, and port, then they're both the same origin. So just to illustrate that in a tabular form, let's look at your pairs of URLs and see if they're in the same origin or not. So the first row, those 2 are in the same origin because they have the same scheme, HTTP, the same domain, goodsite.com. The port number is 80 for HTTP, so that's implied. So therefore, they are the same origin. Now the next 2 are not the same origin because one is HTTP and the other is HTTPS. And likewise, row 3, they're not the same origin because the domain name is subtly different. One is goodsite.com and the other is www.goodsite.com. Row 4 is another example of 2 URLs that are not the same origin, even though they might appear that, because the second one uses a different port 8080. And lastly, another example of 2 URLs that are the same origin because they have the same scheme, the same domain name and port. The only thing that's different is the path on the end of the URL. So now we understand what an origin is, let's talk about the same origin policy. And to understand this, we have to go back, way back to 1995, when Netscape was inventing cookies and forms and JavaScript, and embedding them in one of the early web browsers. They came up with this concept of a policy that specifies whether one JavaScript domain can access the document object model of another JavaScript domain. So to put this in terms you probably understand, one website running in a browser, whether it can access the data of another website. running in the browser. And let's look at that in a pictorial sense. So we'll display the browser as a giant box. So the user is using their browser, and then the browser is going to be talking to web servers somewhere out on the internet. So when the user enters a URL to go to site A, inside their web browser, a context is created to run site A's JavaScript. It has access to the DOM of site A, and usually it'll display the HTML or display the web page in a frame or in a window or in a tab. If they go to another website in another tab, a new context is created in their browser for site B, which is loading the files off the site B web server. And that has its own JavaScript, its own DOM, and its own context, and it's separate from site A's context. And the crux of same origin policy is, can site A that's running in your browser access the data of site B also running in your browser? So the interesting thing about this is that the web browser enforces the same origin policy around whether one site can access another. And it's not actually the web server's job to enforce this, it's the web browser. The web browser is the one that's running websites in different contexts on the user's machine and isolating them from one another and protecting them from one another. So it's the web browser that lets you load internet banking in one tab and Facebook in another, and the web browser is what stops Facebook from accessing the data in your internet banking and transferring funds. So I guess that's a core thing to understand, is that the browser enforces the same origin policy and restricts access from one site to another. Now your web server can influence this. We'll talk a few ways about how you can do that through the course of this talk, but really it's the browser that enforces these rules. And we'll also come back and talk about what happens if it's not a browser that's accessing your web server. What if it's a mobile client, or your site is an API of some sort and people are just calling it from a Perl script? Does same origin policy apply then? And no, it doesn't. If someone writes a Perl script, they can come up with whatever rules they want. They can access whatever data they want. As long as your web server returns it to them, they can do anything they want with it. So our first demo is going to look at what windows can do to each other. So to show this, first I'll introduce our demo sites. Now they're very, very good looking websites. We've got siteA.com and siteb.com. You'll notice they're different colors to make them stand out from each other. Site A is red, site B is blue. If you want to look at the source of the site, it's pretty simple. There's some HTML printing out site A. There's an image which displays an A, and there's some JavaScript being loaded, and it looks like the JavaScript is also printing out an A. So what do we mean by windows? Well, here we've got two different tabs in our browser, effectively two windows, and as we know, they're running different instances, different contexts for those two different websites. When we look at our website, we can inspect the DOM in Chrome's developer tools, and we can do in the console anything that the JavaScript can do on this site. So this is a good way to kind of prototype and figure out would JavaScript be able to do that when it's running in the site. So first, let's look at the document in the current window. And you can see HTML in that document. So you can do document.location, you can change the URL, you can look at items within the document, you can change the document altogether, and there's also a window object, and the window has a bunch of different properties on it that affect the frame of the site itself. So the first thing we want to do is let's open a new window. So this is pretty standard boilerplate code that you've probably done before, and from site A, let's open another window with site A in it. We're going to call the next window right, which is the second parameter. Now you see that the browser just opened up a new window. This window's also got site A in it. And if we come back to our first window, our variable is now defined with a reference to the new window that we've created. Now, it's interesting, there's no way to actually access another window from JavaScript unless you open it and you have a reference to it, or one of the other ways to get a reference to it. If there's a window over here with site A in it, the code in the first tab can't access that because it has no reference. Now we can look at the body of the second window. So we can look at the new one document body, and we'll see that JavaScript in the first window can access the HTML in the second window and look at its internals. What if we decided we wanted to change that HTML? Well, we can just set it to something, and because we've got a reference to that second window, our window is allowed to change the HTML. Now, would that work if it wasn't site A that we opened, but it was site B that we opened? So let's go back to our window opening code. So we're in site A in this left-hand frame, and now we're opening a new window with site B. So we still have a reference to the new window, but when we look at it, what we can see is a little bit more restricted. So before we were able to go newwin.document.body to look at the body of the page in the new window. Now site A is not able to look at the body of the new window. We've been blocked from accessing a cross-origin frame, and the browser's giving a nice message in the console saying that the current site is siteA.com, and it's trying to access a cross-origin frame, and it's not allowed to. So this is the same origin policy at work. The same origin policy is enforcing that siteA.com is only able to access the content of other pages if they are in the same origin as site A. So how does it work with tabs? Well, each tab and window is isolated. So each tab has a separate JavaScript environment, it has a separate DOM, and they're all running independently. But if two tabs are in the same site, if they have the same origin, they may be able to access the data in each other. This is obviously not what you want. If you've got a super secure site, you don't want other tabs in the user's browsers being able to access your data. And that's what the same origin policy stops. Just for the syntax of how it works, when you open a window, you get a reference, and then the window that is opened has a window.opener, which has a reference back to the window that opened it. So if we go back to our example, site B was the one that was opened, right? If we look at window.opener, there's a reference back to the original window that called window.open to open site B. Now we can't look at the document.body because we're site B and that's site A, so the origins are restricted, but we can do funny stuff like change the location of the site that opened us. And so let's change it to Google. And crazily enough, site B can actually change the original site that it opened it to Google. And so we'll talk about the kinds of attacks that allows later on, and why that is. Frames and iframes are exactly the same. So each frame is isolated in the same way that each tab is. They have a separate JavaScript execution environment, a separate DOM, and the parent site that contains the frames only has access to the child sites if they are the same origin. The parent site can refer to child's frames by using window.frames and then indexing into them, or by using their name, and the child frame can refer back to its parent by using window.parent. So let's look at a demo with some frames. So here's parentsite.com, and now you probably haven't seen a site like this for a while. Whoa, check it out, crazy. Oops. So we want to look at the source of the parent site. It uses an antiquated thing called a frame set, and 2 individual frames inside it. Now this is basically the same as iframes, which you probably have seen more of. And what this means is parentsite.com has 2 smaller windows inside it, one with site A and the other with site B. So let's try and see what parent site can actually do to the inner sites. So when we go to the console, we can run JavaScript in the context of the parent site or one of the child frames inside that site. So let's do it in the parent site. Now, the parent site has 2 variables to refer to each frame because I gave them names. So frame A is the left frame and frame B is the right frame. So if we're looking at frame A, can we see document.body? No, we can't, because parent site is a different origin than sitea.com, which is in that left-hand frame. It doesn't have access to look at the body. Now, what about if we're inside frame A and we're running JavaScript inside this left-hand frame? Can we look at our parent? Well, we can get a reference to it, but can we look at the HTML inside the parent? No, we can't, because site A does not have access to access parentsite.com. It's a different origin. So what site A can do, I guess as I showed before, is it can change the location of the parent site. So imagine that this is a website that embeds ads using iframes. It wants to protect, parentsite.com wants to be protected from these ads, so it uses iframes to embed the ads. The iframe site A can actually access window.parent and change its location, maybe to a Google phishing page, and then trick the user into logging back in and maybe capture the login or whatever. So it's interesting to note that iframes and frames can affect their parent, they just can't view the data. And there are sandboxed iframes you can use. You can look into further if you want to do this kind of advertisement thing so that you protect the location of documents. Let's go back to our parent site. Let's change it so that instead of site A in the iframe, it has a subdirectory of parentsite.com. So we've got a page called child.html. Why didn't that work? What's happening? Let's do it in JavaScript. Yeah, so window.frameA.document.location replace child. I don't know why it didn't work when I entered that. Never mind. So now parentsite.com is the wrapper as well as the left-hand frame. So from within parentsite.com and its JavaScript, I can look at my own HTML, and I can look at the HTML of the child frame, child of parent site. So this is kind of what you'd expect. Frames are restricted if they're in different origins, but if they're in the same origin, they're able to view each other's data. And one thing that pages can do is they can also make JavaScript variables. So say I make a hello variable with the value of world. I've made that in the parent frame. So if I print out hello, I get world. If I go into the child frame, because it's the same origin, I don't have my own variable inside my frame, but I can go to my parent frame and look at its variables in the global scope by referring them to them in JavaScript. And so this is how parent and child frames can talk together. Now this doesn't work for frames that are on a different origin. So siteb.com over here, if it tries to go window parent hello, it gets blocked because site B is not able to access a cross-origin frame in parentsite.com. So why is the same origin policy important? Why are we talking about it? Well, it underpins the security of your web browser. The same origin policy is the basic set of rules that the browser follows to protect one web page from others in the same browser. And it's a mostly consistent set of rules that applies to most HTML features, especially the more recently developed ones where they've tried to be consistent, but doesn't apply exactly as you'd expect in some of the older features due to historical reasons. So the same origin policy isolates sites from one another and prevents one website running in your browser from being able to read the data of another website running in your browser. And it allows you to browse the web safely. So the caveat there is, of course, it's dangerous browsing the web and lots of bad things can happen. But the same origin policy protects, is what the browser uses, the rule set that it uses to protect one page from another and to make it safe. So the next section we're going to look at, how does the same origin policy apply to different technologies that you'll use on a day-to-day basis when you're developing for the web.